This is an odd sort of medical type device that I built some time ago. And it's when I'd been looking at some research that had shown that, silver ions can have a sterilising effect on wounds and things like that. And I believe silver-based creams are used in hospitals. And this is basically a little handheld device where you form one connection by holding the case, and it's got a silver probe on the tip, and when you touch it onto, say, if you touch it to yourself, if it was a wound or a cut, then it will theoretically transfer silver ions in sort of, theoretically it's doing it right now, by a very low flow of current, and it will transfer the silver in by sort of electrolysis, sort of almost like electroplating of your skin, so to speak. And the circuitry, there is an LED in the back to show when you're making connection. It's not very bright. Hold on a second, I shall try and shield that and yeah, you can barely see it glowing because it is a very low current. It's measured in microamps because the voltage being used is low. But I'll draw you the schematic and then we'll open the unit up. So the schematic is really super simple. It starts off with a PP3 battery. So PP3, which is the little 9-volt battery. And that's a positive, that's a negative, and the circuitry is as simple as an LED and a resistor. The resistor is 470 ohms, and the primary purpose of the resistor is really to, if the output probe gets shorted to the case, if this was put in a drawer with something and shorted out, is really to protect the LED. And that goes to a probe, a silver probe, which sounds like some bizarre sex toy. Silver probe. The silver probe. The other connection simply goes to the case. That's it. Very simple. And technically speaking, the LED and the resistor could go anywhere since it's a very simple series circuit that is completed through your body. And latterly, I managed to nuke the LED, and I think that was an electrostatic discharge or something, or maybe it was just a bad LED. So latterly, as a precaution, I thought, well, technically speaking, you could get a, if you're holding it and you approach something and there was a static discharge of a particular polarity, it could damage the LED. So all I did was stick a LED, a sort of diode across the LED in opposite polarity so that, if there was an electrostatic discharge, it would protect it. And it's just a little 1N4148 diode. So that's it. There really is very little to it. A very low current will flow, and technically speaking, the ionized silver particles will actually go off into whatever that touches. So let's open it up and see what the construction's like. It's not complicated. I used an aluminium enclosure just because a metal case is one of the connections. That's the bit you hold. Technically speaking, if you didn't have a metal case, you could just make a little handheld sort of electrode for the positive connection. So it's a PP3 battery with a battery clip on it. It's held in place just by bits of stacked double-sided foam pad inside to grip the battery inside to stop it rattling about. It's got this bit of foam here just to keep it away from the side because the screw goes in through that hole. We've got a standard banana style socket, this sort of 4mm socket. Is that 4mm? I think it is 4mm, with a resistor soldered onto the back of it, and the negative is going to the LED and then onto the case. So the negative here is going onto the LED with the diode across it, and then onto the case with this screw. As I say, it doesn't matter where in the circuit they go. I just put the resistor in the positive just because it was easy to solder it onto the back of the socket here, and then the other connection, just because it was an easy way to terminate it. It just went to the LED and then onto the case, because they can go anywhere in the circuit. The probe itself, if I open that up, it's a standard 4mm plug with the bit of solder, silver wire soldered in, because the silver wire takes the solder very well. And then simply it's a little straight length of the solder wire, silver wire, folded over at the end, and then that's it, soldered in, folded over at the end, so that when you actually put it together, it just protrudes out the end as a little rounded probe, because otherwise it'd be a sharp end if it was just straight. The silver wire came in Glasgow. I got it from a bullion merchant. Now, bullion merchants supply jewellers with the bullions, the special metals that the jewellers use, like gold and silver and platinum, in various forms. They supply it as sort of flat strips. They supply it as wires. And in my case, I chose the wire. And this is available. You can get sterling silver, which is additives. It's an alloy. It's designed for jewellery. And you can get what this is. It's 0.999 pure silver wire, which is just high purity silver wire designed for use as electrodes and other things. And I have to say, it might look quite a lot. It might look like it cost a lot. Yes, it did, because silver used to be really cheap until the man-made financial disaster of recent years, over the last decade really. And suddenly everybody started investing in metals that they perceived had a high value. And it meant the price of this went through the roof, and I didn't realise that when I went in. I just went in and ordered just what I'd normally order, like X troy ounces of silver in the particular gauge of the wire. And then they came through the bill after they'd cut it, and it was like, what? Yeah, so that curtailed any experiments with silver electrodes. It had gone through the roof. So that's it. Really simple. The negative connected to the case, the positive connected to the probe with the little resistor to limit the current through the LED. And when you touch it onto a wound or cut and gently rub it backwards and forwards, it will theoretically implant silver into that and sterilise it. I couldn't say if it works. It's very hard to see if anything happens, but it was experimental. It was just one of those things I randomly made.